Welcome back to another video on hybridization of organic chemistry. In one of my videos on hybridization, a student said, "Sir, please, can you create a video on hybridization on chemistry?" Yes, this is the video. Like what I will always say, hybridization is blending of two atomic orbitals, two or more atomic orbitals to form different orbitals. But in this particular video, there are three types of hybridization we'll be working with, which is the sp, the sp2, and the sp3 what hybridization. These are the three major types of hybridization that carbon undergoes. And as long as I'm talking about carbon, I'm talking about what? Organic chemistry. So the first one is, how does the orbital mist? Please take note. Whenever you see this S, I'm talking about the S orbital. And if you see the word P, I'm talking about the what? The P orbital. So this three hybridization in organic chemistry simply means one element must be from one or more elements, yes, must be from the S block, while one or more will also come from what? The P block. So for example, the S block consists of, the S block consists of group 1 and group 2, while the P block in the periodic consists of group 3 to what? Okay, group 8. So group 8 is also called group 0. So that's something I want you to take note of first before we start the video. Now, let me start with hybrid orbital first. Orbital means before we talk about the hybrid orbital. If one S orbital blend with one P, one S can also blend with what? 2P. One S can also blend with what? With 3P. So one S can blend with 1P, one S can blend with 2P, one S can also blend with what? With 3P under what's it called again? Under hybridization of organic chemistry. So if one S should blend with one S, it's going to give us a hybrid orbital called sp. And here will give us what? sp2. Here will give us sp3. Now this sp always have the triple bond. I will only give you the tips. Why this one will give us what? A double bond. Here will give us a single bond. So what is the geometry of this sp orbital? The geometry is usually linear. Here is trigonal. And here is what? Is tetrahedral. Then the next thing is the bond angle. As long as you are linear, that means you must be 180 degrees. Trigonal is usually 120 degrees. And here is 109.5 what? Degree. Apart from this, I want you to take note of something again. This triple bond or this single bond, they have what we call sigma and pi. I want to use that concept, the concept of sigma and pi, but in this particular video. So every single bond has one sigma and then 0 pi. Every double bond has one of the bond is sigma. Remember I said double bond, so one of them is sigma, 2 bond, then the other one is what? Is pi. Why for a triple bond, one of them is sigma, why the other one is what? The other ones, they are what? They are pi. So one sigma 2 pi, one sigma 1 pi, then one sigma 0 what? 0 pi. And a question might also come out in this format. Which of them has the strongest bond? Please, the answer is single bond, followed by double bond, followed by what? Triple bond, because sigma bond is usually stronger than every other bond. So this one, the pi will break to make it very strong. The 2 pi will break to make it very what? Strong. And this kind of reaction, moving from this one from this to this, from this to this, is usually hydrogenation reaction or addition reaction. An example of this compound or this hybridization is the alkyne. Since we are talking about organic chemistry, here we talked about the what? The alkene. And for this particular one, that's where you see your what? Your alkene. So what are the examples, or what are the unhybridized orbital? Please, here I have 0. There's no unhybridized orbital. It means all the orbitals, they are used. And because of that, that's why we always say they are usually saturated. Then how many unhybridized orbitals do we have here? Please, we have 1. And because of one unhybridized orbital, they are what? Unsaturated. Why for this, they are what? Is 2. It is what? Unsaturated. So these are some of the things you need to take note of about the alkane, and what? And the alkyne. So if you have a general knowledge of this, when we talk about the concept of sigma and concept of phi, which is what we are going to do in our next video, it becomes very, very easy because there's actually nothing there. Sometimes they will ask you, how many sigma bond is present in this particular organic compound? It is very, very easy. It's very, very easy just for you to look at the compound and tell us how many single bond is present there and how many double bond is present there. The more the double bond, the more the number of pi. The more the bond, the more the number of pi. The more, or as long as the bond remains single, the bond you will usually be what? Be very, very strong, which is very, very difficult for that bond to break. That bond cannot break. It's very, very difficult for that bond to break. It can actually break, but very, very difficult. It is more easier for a double or triple bond to be broken compared to what? A single bond. Let us do a general recap on whatever we have done so far. These are the three major kind of hybridization in organic chemistry. Assuming you are talking about organometallic compound, that's where you see your sp3d, your sp3d2, that's where you have all that kind of hybridization. But for now, these are the three major kind of hybridization in organic chemistry. We have one S and one P blending to give us sp. And the sp is usually a triple bond. The geometry is linear. The bond angle is 180 degrees, 1 sigma, 2 pi. The example is alkyne. We have two hybridized orbitals and they are usually what? Unsaturated. So just go through whatever I've explained so far and ask your question. I've been able to explain all hybridized orbital. I've been able to explain the bond angle, the geometry, the hybrid orbital form. Please, hybrid orbital form is usually from hybridization. Let me say, when two orbitals blend, the product, that's what we call the hybrid orbital. So this one and this one, when they mix together, what is the product? sp3. So there are three hybrid orbitals formed from this kind of reaction, from the reaction between s and p orbital. So one of the s can react. Some of you will be asking, sir, why is it that we don't have sp4? Okay, let me show you something real quick. The s orbital, why is it that we don't have s2 p4? That's another thing again. The s orbital just have one bus. Let me use one bus so that you understand better. And this bus has 2 electrons, while the p orbital has 3 buses. And this 3 buses 2, 2, 2. What I mean by bus now is suborbital or degenerate orbital. So this is 1, this is 2, this is 3, this is 4. So you can only have s and p will be what? Will be 3. So please take note of that. Then on that question that might also come out is, what is the s character and what is the p character? The s character here is 1:3. Here is 1:2, and here is 1:1. Then if they ask you in percentage, here will always be 50:50. Here should be 33:66, 33.3:66.7. Here should be 25:75. So this is just the general knowledge of what hybridization is all about. In our other video, I will explain how to know how to blend this orbital, because these are just tricks in terms of hybridization. But in our next video, I'm going to explain how to do the organic part of it, how to know this is the one blending and this is the one that is not blending. So if you enjoy what I do, why not smash the subscribe button, like this video, share to your friends, those who find hybridization very difficult. Please remember, my name is Gido Academy and my work is Simplified Chemistry. Goodbye.